Hi everyone, myself Satya, Department of Mathematics, SNS College of Technology, Coimbatore. So already we are in special types of graph. You can see just what is mean by a subgraph, and we are going to see the few graphs. Okay, how to find the subgraph of a graph. Okay, so which is the graph? So for this graph, we are going to find the subgraph. That means we can find few subsets of V and E. Okay, not all. Okay. Yes, so we are taking here V6, V5, V1 and V2. So it's a subgraph. And the adjacency, which is also important, it should, what is the adjacency we are seeing in the first graph? It should reflect in the subgraph. Don't change the adjacency. Okay. Yes. H1 which is a subgraph, but H2 which is not a subgraph, since V3 and V4 are adjacent. Okay. So any subgraph of a graph which can be obtained by removing certain vertices and edges from G, that is called subgraph. It is noted that a removal of an edge, if we are removing the edge, doesn't go with the removal of its adjacent vertices. If we are removing the edge only removed, okay, not the vertices. Suppose if you are removing the vertex, automatically the edges should be deleted. Okay, that is the concept you should remember. And you can see this problem. So it's a graph. Okay, determine which of the following graphs are bipartite and which are not. If a graph is bipartite, then we need to verify whether it is completely bipartite. Okay, yes, first we have to check whether it is a bipartite graph. You can see the first graph. Okay, in G1, since the vertices, first thing is what? We need to find the partition, two partitions. If it is able to find the partition, then go with the concept of complete. Okay, but in the first graph, it is not possible to find the partition. Since the vertices D, E, F are not connected by the edges, they may be considered as one subset V1 and ABC as V2. Okay, so from this we can say it is not a bipartite. Since the vertex is V1, which is connected by the edges to the vertices of V2, but the vertices of V2 are the edges AB and BC, which is not in the list. Okay, hence it is not a bipartite graph. And the next thing is, from second graph we can consider V1 as A and C and V2 as B, D, E. So which is bipartite, because we find the partition, right, in such a way that we have to verify every vertex of V1 which is adjacent to every vertex of V2. That is called complete bipartite. Okay, so A and C both should be adjacent to B, D, E. So from the diagram, from the graph only, I have to check those things. Okay, so the remaining thing we will see. It's a bipartite graph. So from this we can say it is completely bipartite. And in G3, V1 is ABC and V2 is DEF. Hence the graph G3 is bipartite. And the next thing is we need to verify whether every vertex of V1 which is adjacent to every vertex of V2. So here the vertices A, F, C and D, which is not connected by the edges. So from this we can say which is not a complete bipartite graph. Okay, right? It is bipartite, but it is not completely bipartite. And the next thing is draw the complete graph K5 with vertices A, B, C, D, E. Draw all complete subgraphs of K5 with 4 vertices. So K5, 5 vertices, it should be connected, right, that way, because it's a complete graph. So in every pair of vertices we should have the edge. That way I have to draw the graph with 5 vertices. And take all 4 vertices. Suppose we are going to delete the vertex A from the graph. That means I have to delete AE, AD, AC, AB, those edges. Okay, we already know the concept, right? And in the next second graph we deleted E. So correspondingly I have to delete its corresponding edges. Okay, that way we formed 4 subgraphs. So when the vertex is deleted, automatically the edges which is adjacent to it is also deleted. Okay, I think now you know the concept, right? So what are the things up to this we revised? Yes, so what is mean by a graph and what is mean by vertex, self loop, basic terminologies, and in degree, out degree. Okay, and in today's class we just revised special types of graphs. Yes, what are the graphs? regular graph, complete graph, bipartite graph, complete bipartite graph, and subgraph. Okay, and based on that we saw few graphs. Okay, for that. Okay, so the remaining thing we'll see in the next class. Thank you.